Exploring Pytorch on Raspberry Pi. Hands-on tensor data manipulation for AI enthusiasts. Welcome to Inside Builder channel, Python experts and Pytorch enthusiasts. This is part 9 of multi-part series where we are looking at the various modules, methods that we can work inside the Torch module, Pytorch module. If you look at the earlier videos in this playlist, you will be seeing a mix of basic Python as well as Torch module related videos. The idea is to use the machine to learn stuff, to do stuff by itself. And in order to do that, we have to ground up train it. And Torch is one of the modules in Python that can provide the models for training the machines. So in order to train the machines, you need to have models. And we saw in the earlier videos how to create basic linear model, and also we saw how to modify the data to move through the linear model. So we did a flatten option, we went through softmax, we went through the dropout layer, etc. And then we tried to modify the data with the linear layer. In this video, what we are going to do is we are going to work on loss criterions or loss calculators. The purpose of loss calculators is pretty straightforward. The loss calculators tell the model how good it is in predicting the results. It's a simple function to see whether the model is predicting better or worse than the reality. If it is predicting worse, there should be the algorithm to correct it. If it is predicting above the best, then there should be a way to correct it. So that is where optimizers come in. However, the idea of even getting the loss and then making the model learn is what we are going to see in this discussion. So the discussion that we are going to do is Pytorch back propagation explained by looking at what happens when we do the neural network training. So we will be taking in order to do this, you have to first of all see how the back propagation happens in Pytorch. So let's first, we will be getting the view of the BP process, that is a back propagation process, as a module, as a flowchart, and then we will create the parts required for the back propagation and look at the internal workings of the parts. That's what we will do in this discussion. Let's jump into the back propagation module. So here you are looking at a flowchart of back propagation in action. So there is this particular operation where we are providing the input data point X and providing the model weights, that is W, and we are operating it using the matrix multiplication. And then we are trying to, this multiplication provides the Y hat. Basically, that's a prediction of the model that is still in training. After this prediction has been done, then we have the original data point, that is Y, which is compared with the predicted value, that is Y hat, and the loss is calculated. After that, we have to do the loss functions. We have various kinds of loss functions. We execute that and we get the loss out. On the loss, we start doing the back propagation. This algorithm is one of the most confusing aspect of neural networks, and there are so many discussions that is happening on the neural networks, and how to implement it in Python, in various other languages. Important point is that even though you can see this particular block diagram, you can see how the data is entering and what kind of modification we are doing, the best thing is to look at the actual working. For that, we are going to go to the Torch window itself. So I am going to import Torch. So I'm going to do a couple of things here. So just a second. I'm going to follow through this process. I'll be sharing this entire process in the description of this video. You can also do the practice. The most important aspect is to do the practice and then look at the data. Once I execute this particular code, this particular table, you'll see that it errors out because this is just the comments that I'm going to use. I'm going to import Torch right now. Import Torch, and then I'm going to import from sklearn. I'm going to import datasets. Datasets is one of the modules that can help you to create artificial datasets. From this datasets module, we can create a dataset for regression problem. So we can say x comma y is equal to, because the output that comes from this particular function will be a tuple, so I'm using x comma y. So I say datasets dot make regression and if you do a shift tab, you will see the various arguments we need to provide for this particular function. So make regression is a function that we are going to use and get the data back. So I'm going to say n samples. I need n samples. I'm going to ask for 100 samples now. So basically I will get 100 data points. That's what I'm asking for. 100 data points, and each data point should have at least 4 features, and the target should be single feature. So I am going to make it simple. And finally, there are 2 more things I need to provide. The noise, since it is going away, beyond the limit of the window, I'm going to modify it. I'm going to take a noise of 25 and the randomness state of 1 2 3 4. So if you use this random state of 1 2 3 4, you will also get the same data that I get in this particular run. Anyway, that's not what we are actually after. So we have to create the tensor. In order to do that, we need to also import numpy. Import numpy as np. Import numpy as np. Then we create the tensors. In order to create the tensors, we have to use the torch dot from numpy, and numpy, these 2 variables are numpy data right now. So you can actually call as type x dot as type, and you can ask it to be of float 32, because that is float 32 is required for our tensors to go into the backpropagation process. So that is required. Same way, I'm going to convert y, and I'm going to name it as y. Apart from this, I need to actually change the shape of y. So for that, I'm going to do this y view. I'm going to say y view, y dot view -1, 1. So basically I want one single column, multiple rows, 100 rows basically. So all the sample data points, I need one target. So once I'm going to execute this, you will see that it has got created. And now if you look at the y, you will see that it is it is having a lot of rows and single column. And x will have multiple hundred columns with 100 rows with 4 columns. We have both of these things. Next, what we need to do is we need to go up and take a look. So always review the steps that you need to take before you start a problem. Always write the steps. This is one of the challenging aspects for people who are beginning new. Why this becomes a challenging aspect is that you have not still seen what are possible. So initially it will be difficult to write these things, but once you have learned how certain things work, after that, whenever you are practicing, first of all, write what you are going to do, every single step of it. First write it, and then try to write the code for that. Initially, when I was practicing the coding, this was a challenge for me. Once I completed the process of understanding the entire coding process, getting used to all the syntax and the ways of solving problems, then writing it became way more easier. this is usually called as algorithms or pseudocode, but it's more like, discussing your ideas to you with yourself. That's how I see it. Next, we are going to create. So we have the data, we have got the tensors ready. Now we are going to create the model and the loss function. In case of model, we are going to simply use we are going to first of all import the NN module. So from torch import NN, and we are going to ask for the model linear model, and in features are going to be 4 because we have 4 featured x data point, and out feature is going to be 1 because the target is 1. Once you execute this, you have to take a look at one important point, that is the weights. So what are the weights of the model when it got initiated? How to look at it? So for that, we can use something called as the attribute. So the model itself has an attribute called as weight. That's simple, right? So this is the weight that is going to be modified, and this weight is actually requires gradient, meaning this weights can change as the training happens. Why I am showing this weight in the beginning is because we are going to look at this particular point again and again as we progress and start working on the training. We will be doing a single loop of training only. So let's proceed. Loss function is equal to nn dot msc. We are going to use mean square error loss, and I'm not going to discuss about how that loss is calculated, what is the background of it. I would suggest you guys to take a look at the documentation. What you're going to do next is we are going to create a prediction using this model. So in order to create the prediction, we are going to take only one prediction. In order to take one prediction, we have to send only one data point. So I'm going to take X tensor, and I'm going to only send the first row of the tensor. That is going to give me one prediction. So if you take a look at it, it will have a single tensor output. So you see that it is having a single tensor output, but it can be used for view backward calculation. Next, these backward, you see these, right? Request grad, view backward. These are the functions that are going to be acting upon when the backward pass starts. So when and where the backward pass starts, that's very, very important. Let me now calculate the loss. So loss val is equal to loss function, and inside the loss function, I'm going to give the y predicted, and I'm going to also give the first y data point, because I took only the first x data point, right? I'm going to only check it with the first y predicted data point. Once I do this, the loss value has been reported. So if you take a look at it, the loss value is reported here. So the loss value is really, really huge, and the backward calculation has to be done on this loss value. If you go to the back propagation, on the loss, the backward pass starts. Not on anything else. On the loss only the backward pass starts. So we have to, just a second. So now we have the loss value. You have to just call loss value, and from there you have to call for the backward method. So loss val dot backward. So simply calling the backward method like this itself is sufficient for the weight gradient to be created. So what is weight gradient that I'm talking about? Now if I go to model dot weight dot grad, so weight has one more parameter called as grad. So if you execute this, after you have done the loss val backward method, you will see that it has got a gradient value. So this gradient value is what we are after. So based on this gradient value only, we will be modifying the weights. So you see the weight calculation has been completed, and it took considerable amount of time because we are running this entire setup in Raspberry Pi. And in Raspberry Pi, once we are asking for the backward calculation, it has to do it for all the tensors. So it takes time. If I, for an example, create a new model. So if I say model new, and for new model I say nn linear, and I say number of features is equal to in features is equal to 2. I'm just giving an example here, so just to show you what happens to the grad in the beginning. You will see that it doesn't have a gradient at all. So if you go to the model new, and if you look at the weight dot gradient, it will be none. You will see that nothing is printing, but if you do a print on this print function on this particular grad attribute, you will see it's none. So only after you are done the loss backward, this particular backward the weight gradient gets calculated by the torch module itself. So you don't need to do any of these things. You have to just call backward and it will calculate it till all the weights. If you see all the various videos, you will find that they explain to you how the backward calculation works, but I am not going to explain that. See, at the end of the day, that has been completely abstracted away. There are lots of research that has been done on that. My intention here is primarily to make you understand how the backward calculation happens, and where to look for the value. Once you are having this intuition, then you can really think what happens when you're going to loop it. So now I am only sending in one data point. Now think what will happen when you're going to send all the data points through it and for multiple times. So that is called as training. It's as simple as that, guys. So, but we have forgot one important step. After we look at the weight grad, the weights gradient value, we have to use the weights gradient value and we have to modify the weight. So for that, we have to say torch no grad. So you have to use this particular decorate or width function, and you have to change the model weight. So you have to say model weight model.weight is equal to, usually there will be a learning rate of, I am taking 0.01, just excuse me, 0.01 learning rate, and I am going to update that model weight dot grad, and I'm going to reduce this from the model weight. So once I execute this, it will actually execute and the model weight would have got modified. So if I now execute model weight, you will see it is 2.073 minus 1.024 and 0024 1.3937 and so on. If you go up, if you look at the where the model was created, you will see it is 2871 minus 3109 minus 4713, and here it is completely different. So what has happened here is basically that the gradient has been updated into the weights, and now the model is ready for the next step. But before we go for the next step, we have to ensure that we do a zero grad on the model. So once you do zero grad on the model, what will happen is, now if you take a look at the weight, it will not have a gradient at all. So this is the process. Now you see the same model does not have the gradient. When we do this again and again and again for multiple times, the entire model weight starts learning, and steadily the losses reduce, and that's where the losses are reducing, that's where the optimizer comes into picture. In this video, I just want to touch on the basic MSE loss function, and along with that, I want to show you how the backpropagation works and how to look and understand intuitively what is happening inside the Pytorch methods when the backpropagation happens. I believe that by this video you have got some clarity on how this entire backpropagation happens, and also how you can visualize it to for your future model generation process. So take a look at this video again and try to process this steps that I've already provided here, and practice it. So at least do it some 10-15 times to become very, very fluent with this process. After that, only proceed for bigger data sets where you can push the data set without even thinking as a pro. So that is one of the important point. You can work like as if you are a pro. So Pytorch backpropagation explained video is done, and we have also recapped what has gone through. So With this said, in the next video, we will be diving into the optimizers. Till the next video, practice, 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 practice. See you guys. Have a great time.